All right, so now we're going to try to approach the sum in a different way. Let's say we didn't think to do the integral test. And this is kind of foreshadowing for the next chapter,
Okay.
which is on the comparison test. So we have two possibilities. So if we think something converges, like we think this converges, we want to compare it to a series that we know converges. And do we want it to be bigger than that series or less than the series?
We'd like it to be bigger. Actually. No, because I mean, so the series bigger than this converges, then we would know this series converges.
Okay, so do we want this series to be larger
We want
or
this
smaller?
series to be smaller.
Okay.
We want the series that we're looking at, our approximation, to be bigger.
Okay, and now we have not talked about the comparison test at all, so I'm asking you a question that's something we haven't talked about at all. But what series do you think would be worth comparing this to?
So maybe 1 over n cubed
Okay.
could be useful.
Yeah, because it looks like that's what it's going to look like at infinity. So let's take a look at 1 over n cubed minus n over n to the 4th plus 1. And what we're hoping is that this, if this converges, which is what our intuition says, we're hoping that this, stupid marker, we're hoping that this is smaller than this, which means this difference will be what?
Finite. These both converge.
No, we're just looking at the terms. So we're looking at term by term, 1
Yes.
over n cubed minus n over n to the 4th plus 1. So if this is smaller than this,
Yeah,
that difference will be
positive.
positive. Okay, so we're trying to see if this is positive. So go ahead, see what you see.
So we can just subtract like we would subtract fractions. So so we get 1 over n to the 7th plus n cubed, which, since n is always positive, this is always positive.
Okay, so we found a nice series to compare this to. And it turned out that the series with this term converged. The difference between this term and this term was always positive, which meant this is always smaller than that one. And so we're good to go.
Mm-hmm.
Okay. Now let's just pick one more random problem out of the book and see what we can do.